Many companies are looking to distribute their data centers across geographies. These might be in the same state, it might be across states, it might be across the world. The reasons that they do that are many. First of all, to ensure business continuity. Second of all, to get the applications closer to their end users. Another reason might be seamless workload mobility, or being able to seamlessly move server instances from one data center to another, and the ability to maximize their investment in compute resources. In order to support these distributed data centers and get the most return on investment, many customers are looking at ways to interconnect them with a technology like Data Center Interconnect. Now, Data Center Interconnect is not necessarily a specific technology, but there are a number of technologies you can use to connect your data centers. Now, in the past, there have been many challenges in the way we traditionally deploy Layer 2 across multiple data centers. We use a few different technologies, for instance, leveraging dark fiber in between data centers that are fairly close to each other. Usually those are connections that a company owns or leases from another company, but gives them total control over the connectivity between the two data centers. We might use Ethernet over MPLS or VPLS, Virtual Private LAN Services. Ethernet over MPLS can be used to provision point-to-point Layer 2 Ethernet connections between two sites using MPLS as the transport. MPLS, once again, is multi-protocol label switching. VPLS is similar to Ethernet over MPLS. VPLS uses an MPLS network as the underlay transport for the network. However, instead of point-to-point Ethernet pseudo-wires, which are basically point-to-point virtual connections, VPLS delivers a virtual multi-access Ethernet network. If this sounds complicated, it is, which is why there are a lot of considerations to take into account before you connect two data centers with Data Center Interconnect. In some cases, like I mentioned previously, dark fiber may be available to build private optical connections between data centers. If you have a large amount of dark fiber, that's a great thing. Most people don't and have to take advantage of technologies like DWDM, or Dense Wavelength Division Multiplexing, or CWDM, Coarse Wavelength Division Multiplexing, to increase the number of Layer 2 connections that can be run through the same physical fiber connection. Traditional Layer 2 VPN technologies can provide extended Layer 2 connectivity across data centers, but these technologies usually involve a mix of complex protocols, distributed provisioning, and an operationally intensive scaling model. The provisioning of many point-to-point connections or the complexity of the underlying transport technologies can add significantly to the operational cost of these data center interconnects. A simple overlay protocol with built-in capabilities and point-to-point provisioning is crucial to reducing the cost and providing this connectivity. Traditional Layer 2 DCI technologies often do not allow for concurrent use of redundant connections because of the risk of Layer 2 loops. Balancing the load across all available paths while providing resilient connectivity between the data center and the transport network requires added intelligence. Traditional Ethernet switching and Layer 2 VPN do not meet that level of intelligence. Other things to consider when determining what type of data center interconnect to use are: what is the flooding behavior of this specific technology? Does it propagate unknown unicasts? Do unicast floods reach all sites? Also, you want to take a look at failure containment. The extension of Layer 2 domains across multiple data centers can cause problems. Traditional Layer 2 extension technologies between multiple data centers often extend the failure domain between the data centers that are causing issues. these failures propagate freely over the open Layer 2 flood domain. A solution that provides Layer 2 connectivity yet restricts the reach of the flood domain is needed. Such a solution would contain failures and thus preserve the resiliency that is achieved by using multiple data centers. One of the technologies that we will be talking about for data center interconnect in this course is Overlay Transport Virtualization. OTV is a feature that is provided by the Nexus and ASR product lines and delivers a virtual Layer 2 transport over any Layer 3 infrastructure, and does so in a way that is efficient, optimized, and reduces fate sharing. Please join me for the next lesson, differentiating between data center interconnect and network interconnectivity.